for more to show up. There's 2 people there. Well, 3 counting you.
Sorry, Maddie's not even here.
Who?
Madison.
Oh, yeah, Maddie, yeah. So we're going to continue reviewing for chapter 5. And as a reminder, this is what we were doing last time. We were looking at interval notation, and I don't know that we had really started that yet, but we were also doing intersection and union of sets. And since that was so last week, I'm gonna like glaze over this real quickly. And instead of last week we used names. I'm gonna say set A is 0, 1, 2, and 3. And set B is 2, 3, 4, and 5. When we did the intersection of sets, which was an upside down U, this means data in both A and B. Well, we're looking for numbers that appear in both regions. A intersect B is only the numbers 2 and 3. So it has to be in both. Apple's usually a good one too.
I have a lot of my money just like broad market index funds right now.
I like the spider index. It follows SPY. Does like it does a lot of tech companies. Tech companies really got hit by the pandemic, but basically over, and so should be on the up and up now, as you see with Meta. And then, so that was A intersect B. Then we had A union B. This is data in either A or B. Let me get a new green pen. I carry spares. Be prepared. So data that's in A or B, well, that's going to include every number that's in A and every number that's in B that wasn't already in A again. I don't need to list 2 and 3 again, they're already there. But I do need to list the 4 and the 5. So that's A union B. Ready for more? All right, I'm gonna flip the page because I need more room. Well, grab the next page, I didn't actually flip it. So let's look at a couple sets written in another form. And to proceed with this talk, I need to use this symbol with you guys. This is Buzz Lightyear's thing, to infinity and beyond. This is the infinity symbol. But in reality, infinity has no beyond. It's the largest possible number if there was a largest. But there isn't, because no matter how big of a number I say, I can always add 1 to it and it'll be 1 bigger. So this isn't really a number, it's not a number, it's a concept. Where is that going to come in? I'm going to write a number line. I'm going to put 0 on it. On the number line, when the arrows keep going, the right one goes towards positive infinity, and the left one goes towards negative infinity, which is the most negative possible number. So let's start drawing depictions of what we see here. Set A here is x is less than or equal to 6. I'm going to draw the lines below it rather than on it because I got 3 different lines I want to draw. But set A starts at 6, and it's all numbers below it, numbers that are less than 6. And since we have the equal portion to it, we're going to fill it in. This is set A. It's got a solid endpoint. Set B is x is greater than or equal to 2. It starts at 2 and keeps going all the way up. And since it has an equal portion, we're going to fill it in. This is B. It's also a solid point. And finally, C, x is less than -1. We put a circle at it. Numbers less than -1 are to the left in it. And since it doesn't have an equal sign, this is going to stay hollow. Hollow point. So some rules about the solid points and the hollow points. So for solid points, this occurs, what it means is, this means include the number in the set. Or solution. This only shows up with greater than or equal to signs and less than or equal to signs. And in terms of interval notation, these correspond to a left bracket, and that one corresponds to a right bracket. I think the easiest way to recognize this is the equal sign has a horizontal bar for these. Recognize that this is a horizontal bar there. Horizontal bar on both. If we look at the hollow points, this means include values close to this, but not this number. This corresponds with your greater than and less than symbols. And in interval notation, these correspond to parentheses. The greater than tends to go with that one, and the less than tends to go with the right one. And the other thing we use parentheses for, these are also for infinities. I'm giving you the rules. I think when you see them written out, this is going to be like a lot clearer. You'll be like, oh, that's pretty straightforward. You guys ready for some more? Okay. So I'm going to leave that up there so we can write down a couple ideas here. Let's do set A and B and C. Let's do the interval notation for these. X is less than or equal to 6. I think an easy way to do this, if you have the number line, start at the left side of the number line, and wherever it starts, write down that number. Here it starts at negative infinity. And I'm going to keep going, and wherever it stops, I'm going to write down that number. It stops at 6. We'll put a comma between them. The first number is always the start number. The second number is always the stop number. And the start number is always less than the stop number. You always put them in low to high order. Lower to higher order. Now for brackets or parentheses. I said solid points get a bracket. They have something, this looks like a bracket or a bracket. In this case, the 6 has the bracket, and we're trying to encapsulate or enclose these values. So the bracket's going to go like that. It's going to be a right-hand bracket. This is because of the solid point. For the infinity, it's not a real number, so we can't include it, so we use a parentheses. We have that one there because it's an infinity. With me? Set B. X is greater than or equal to 2. I am going to do that same thing. I'm going to start, and wherever my blue line, my B set starts, I'm going to write that number. It starts at 2, and it ends at infinity. Well, infinity never ends, so it keeps going towards infinity. The 2 has the bracket because there's an equal portion, and infinities are always parentheses because we can't ever include an infinity. It's not a number. So on this one, I want red. That's a bracket because of the solid point. And that's a parentheses because of the infinity. Set C is my red set there. X is less than -1. If I follow this same principle here, it starts at negative infinity and it ends at -1. Negative infinity always gets a parentheses. And -1, it's a hollow point, so we're going to go parentheses here as well. That's for the hollow point. That's for the infinity. You guys ready for some more? Okay, right now we were just showing interval notation. Now let's combine that with intersection and union. So I'm gonna make a new set. We'll call this one D. We're gonna make this A intersect B. So remember, intersect is like and so we're looking for regions of overlap. So we're looking for this region right here. This region starts at 2. They both have a 2, and they both start at 2, or they don't both start at 2, but they both have a 2 in it, and that's the lowest number they have. And the highest number they both have in common is a 6. And since both values are on the number line, we are going to use a solid bracket for both. So both of these are solid points on the graph. And then let's do set E. Let's do B in union with C. The union is the or symbol, which means in either. So if I were to redraw this down below, the C starts there, goes up to -1, and that's C. And B starts at 2 and it has a solid point, and it goes all the way over to positive infinity. This is negative infinity. We're going to do the same thing here. Start from the left, write down the numbers where they start. This set starts at negative infinity, and it goes up to -1, and it stops. So we've got to start, and we've got to stop. But then it restarts at 2. And it ends at positive infinity. So we have another start and another stop. The infinities always get the parentheses. And the hollow point gives a parentheses. The solid point gives a bracket. Since we have 2 regions, we're going to use the union symbol. I do want to point out something. Notice this is the information for C, and this is the information for B. Don't automatically write it in the order of B union C. Put the interval notation in the order of the request. If I wrote B union C and did this in interval notation, the way it looks is 2 bracket infinity in union with negative infinity, -1. And this is wrong. This is breaking the lowest to highest rule. You guys ready for some more? Got one more thing, 2 more things I want to touch here. I'm going to put that number line back up. We did A intersect B, now let's do A union B. Again, this is an OR, which means as long as, when I do the left to right, if it touches either line, I'm going to include it. This line starts at negative infinity. The green line starts at negative infinity. So we're going to include it. And although the green line ends at 6, the blue line keeps going up to positive infinity, so we're going to go all the way up to positive infinity. And both of these get parentheses. Another way of saying this, they will put this, which means all real numbers. The other funky one we got going on here is if I do B intersect C. Which part of the number line has both lines? Nowhere. C and B don't overlap. We don't relate, there's no interval notation for this. Interval notation, none. We don't write this. This is the empty set, which is the same thing as saying empty brackets or writing empty set. They don't overlap. I do want to write this A union B. I want to put it how you would see it in the X's. Here, I would see this as negative infinity is less than X, which is less than positive infinity. That's the other notation for this. This is not interval notation. The black set is the interval notation. The red set is just the regular algebraic notation, I guess is what they would call it. Let's go back and touch on some of the other ones I didn't put those for. Let's see. We did those. Set D. This is the same thing as writing 2. The solid one means a less than or equal to. The brackets give me that equal portion, and it's between 2 and 6. Another way of putting this is 2 is less than or equal to X, and X is less than or equal to 6. So it has the and in it. When we do the or, the union, this is going to have negative infinity is less than X, which is less than -1. That's for this region right here. Or 2 is less than or equal to X, less than infinity. And there's no way of solidifying those into one statement. Here, we were able to turn the and into one statement. The or you have to keep separated. And in all reality, you would probably just say x is less than -1 or x is greater than or equal to 2. That's probably how you would say it. You wouldn't include the infinity signs. You guys ready to try some? All right, let me give you guys some sets, and I'll pause the video while you guys work on this, but let me put them up first. We're gonna do set A, x is less than 4. Set B, x is greater than or equal to 2. Set C, x is less than or equal to -3. To start off, write those in interval notation. Then try I should say try A union B. I gotta keep it on screen. A intersect B. B union C, and B intersect C. I'll make this recommendation to you. You can heed it or not. I would try writing these as interval notation without doing the number line. Then do the number line with the arrows like I did, and see if you, when you do the left to right with your pencil, you get the same interval notation. With enough practice, you don't need to draw the number line anymore, but until you're comfortable, you should draw it. I'm going to pause the recording for a second while you guys got hung up. Were you guys able to do this set A? So, I'm hearing crickets. If you don't know how to do it, write a number line. You know what, I'm going to put the number line down here so I have a little more room. 0 goes in the middle, and as numbers go to the right, they get larger, up to infinity, and as they go to the left, they get smaller. So set A, x is less than 4, which means I want to start at 4. And I can draw a line if you have, this always works like this, check this out. If the variable is on the left, this symbol acts like an arrowhead. My line is pointing to the left. This only works if the x is on the left. If the x is on the other side, on the right side, it's pointing in the wrong direction. That's my A. Now, if I put a little pin there and slide the pin from left to right, it starts at -infinity, and it keeps going, and it stops hitting the red line at 4. Right? The infinities always get parentheses. And the 4, we need to decide if we want to use a parentheses or a bracket. The parentheses are when we don't have an equal sign or when it's hollow. So we're gonna use a parentheses here. Does that make sense? Try doing the same thing with B. Did you guys do the number line?
For me, it's the ors and ands that I'm really hung up on.
Okay, is that the same for you, Jared? Did you do B and C? Okay, so for B, you should have gotten 2 to infinity, bracket, parentheses. And C, this is B. And C is -3 and less than. That's C. So we start at negative infinity and we go up to -3. Negative infinity gets the net parentheses, -3 gets a bracket. You guys got those, right? Okay, so A union B means or. It means it has to be on the A line or the B line. So, start from left to right. As long as my pencil hits either the A line or the B line, we're going to include it. The arrow technically goes all the way over to negative infinity. So this starts at negative infinity. And we keep going, and the A line ends at 4, not including 4, but the B line continues. And since this is an or situation, we're going to keep going, and this goes all the way up to infinity. And the infinities get this. So for the union / or, see if either line is touched. Is counted, I'll say, as we go left to right. When we do the intersection, or the and, see if both lines are present. See if both lines count as we go left to right. Did you guys draw the number lines like I did down here? Okay, before I continue, draw the number lines or use the ones I have up here and try to see if you can interpret or figure out what they are from here. You'll be really doing a lot better if I let you struggle through this and you figure it out rather than I just continue and you're like, all right, whatever he says.
I drew it as you drew it just now, but in the initial work session, I did not.
Okay.
It makes it a lot easier.
So if you try to do it without the number lines and you get stuck, draw the number lines. Until you don't need them, until you can do look at 5 or 6 of these, even with the union and the intersection, and write down the interval notation without doing the number lines, do the number lines. It's a skill that's acquired with practice.
write it out in like interval notation, but only the numbers that are included within both.
Yeah, so it's only the numbers that are on both lines. You got them all?
I think I do.
Jared, you good?
Maybe.
Okay, but you've gone through them? Okay, let's try them together. Let's see what we get. So, A and B. A and B, we're hitting A, but we're not hitting B yet. We're not hitting B yet until we get to a 2. We start hitting B when we get at a 2. We start hitting both at a 2. When we get to the 4, we stop hitting A. Even though B continues, A doesn't, so we gotta stop there. The 2, even though I don't have a dot there, it is on the line, so the 2 is in both sets, so I'm going to include it. The 4 is not in both sets. The 4 is in B, but not in A, so we're going to use parentheses. In B, not A. Now, the next one's pretty tricky too. We got B union C. So as long as it shows up on one of them, we're going to include it. It shows up on C right away. It starts at negative infinity, and it goes up to -3. And then it stops for a while, and then B starts back up at 2 and goes to infinity. The infinities get parentheses all the time. 3 was a solid point. It had the less than or equal to, it gets the bracket. 2 was a solid point. It gets the bracket. And we do the union symbol when we have 2 different regions. And finally, what's in B and C? Nothing. There is no overlap between B and C. Which means this is the empty set. Or we can do the empty brackets, or we can just write empty set. Did you guys, how did you guys do?
I was able to get it, I got them.
You got them? How about you, Jared?
Not close.
Close? Did you see where you made a mistake?
Yeah.
And so, like, you're good? You don't want me to go over with you? Or do you know what you do? Or is it one of those, I don't know what I did wrong?
I can see what I did wrong.
Okay.
Maybe the number one has a line.
Okay, cool. Awesome. Yeah, definitely do the number line if doing it without. In fact, do the number line until you think you can do it without it, which probably isn't going to happen in this class. Since we're not doing algebra class, we're not going to have a lot of this in here. But if you wanted to really like learn it and master it, do it without it. Like make up just a bunch of sets and try to write it. Do the X is less than this. Do it with the less than and greater than shit like that. Try to write it as interval notation. Then do the number line. And then once you've mastered, like once you your interval notation that you did before the number line matches the one after the number line. You do it like a bunch of times in a row, you've learned it. Until then, you're like better off doing the number line until you think you can pull it off. All right, so this is where we switch to a related topic. This is on linear inequalities. So in this stuff, they look like linear equations. We solve them like linear equations. Except there is no equal sign. Just our inequality symbols. And we write the solution in interval notation. There are two exceptions to solving like equations. Two exceptions when solving. We will flip the inequality sign. Like this will turn into that, or that will turn into that. That's what I mean, flip. Under A, if we multiply or divide by a negative, by a negative number, or B, swap sides without adding or subtraction, without addition or subtraction. And what I mean by that is if we start with like x is greater than 3, and I put the 3 on the left and the x on the right, the alligator is chasing the x, the alligator needs to stay chasing the x. You guys ready to see a couple of these or start this? Start with something simple. 3x minus 7 is greater than 14. How would I solve this if that was an equal sign? There we go. Don't be afraid to answer a question in class, even if you're wrong. Ain't no one going to criticize you. Half the people in the class are probably wrong with you, and by giving the wrong answer, you'll get the teacher to show the right way. In this case, you did the right thing. Now what?
Divide by 3.
Divide by 3. And I get x is greater than 7. What would that look like in interval notation?
So that would be 7 comma infinity with parentheses on both sides.
That's what Cody got. Jared, what did you get? You got the same thing? Good, because that's the right thing. Just wanted to make sure. See how you guys are doing. Did you guys draw a number line?
No.
Progress. Baby steps, right? The interval, like when you have the and or the or, that takes a lot longer to get comfortable writing.
Yeah.
That's like number line shit for a while. But hopefully the ones where it's just a single combination, it gets kind of easier, quicker rather than later. Okay, let's kick it up a notch. What should we do here? Let's make sure everyone's on the same page. What's our first step?
Add up the parentheses,
Do what with the parentheses?
add them up
How?
by adding the extra,
Well, how would I do that though? I don't know what x is.
by writing it as 1x.
No, okay, that's different. So I'm glad I brought this up. Let's pause real quick. Let's come back to this. Let me do another page real quick. So x plus 1 versus turning that into 1x. If x is 2, what is x plus 1? 3. Over here, if x equals 2, 1 times 2 is 2. So this means 1 times x. When you have 1x, it means 1 times x, and we generally don't write it. We just generally put x. I'm glad I asked. I'm glad you said that, because this is a common mistake. And I'm glad I don't always think to address it until someone's shows the mistake. These are not the same thing. So until we know what x is, we can't add 1 to it. Because if it turns out, like when we solve it, if x ended up being, -3, then x plus 1 is -2. And so I don't know where it's gonna be.
So instead we would use the distributive property and multiply it out, right?
Yeah, let's do that. Let's give that a try. We do want to deal with the parentheses. So let's deal with the parentheses. And the way we deal with them is we distribute that 3 to both. 3 times x is 3, and 3 times 1 is 3, and we have a plus sign between them. And you guys should always, always, always write down everything else that you didn't change. I oftentimes get students that just show that operation and try to get down to the end and invariably fuck it up, like 90% of the time. If you don't write down the shit you didn't change, you start losing that information as you go down. Now what should I do here?
I would add 6 to both sides.
We could do that. So what am I getting on the right?
+4.
Let's see, 3 minus 5 is -2, plus 6 is +4, yes. So adding 6 to both sides work if you need to. If necessary, do this first. That's for people watching at home and stuff. Do the 3 minus 5, have the -2, then add the 6 and get the +4. Now what? Let me show this a couple ways. I got 2 options. One option is move the x's to the left, and one option is move the x's to the right. Let's do both ways. So if I move the x's to the left, that would require subtracting 3x from both sides. And I get 2x minus 3x is -x. On the right side, I get 4. Then I would need to divide through by a negative number. Even though I don't see the 1, there's a -1 there. I get x and I get -4. But I divided by a negative number, so I'm going to flip the inequality. Let's do it the other way. I move the x's to the right. I subtract 2x from both sides. And I get 0 is less than x plus 4. And I can subtract 4 from both sides. I get -4 is less than x. These two are both correct. If you like writing the x on the left, as a lot of people do, if I switch x and -4 here, then my alligator mouth has to change with it. The alligator is going to continue chasing the x. Is okay? Let me give you guys one to go with, and then we'll do it together. And I'm going to pause the video so that people watching at home don't have to just sit here and watch it pause for a while. So I started recording, or not recording. We had 2 students, for the sake of anonymity, we'll leave them a name for this. One got n greater than -3, one got n is less than -3. And so we started walking through what the correct answer is. When you divide the -4 by -4, or -4n by -4, we gotta flip that sign. So it should be the n is greater than -3. If you got n is less than -3, don't fret. It's a common mistake. It happens all the time. So what you can do is if you find yourself making this mistake, forgetting the negative, instead solve it like this. Instead solve this way. What I'm going to do is I'm going to add 4n to both sides. I'm going to make it so my coefficient is positive. Coefficient is positive. I can't make that mistake. Now I need to get n by itself, so I'll subtract 12 from both sides. And I get -12 is less than 4n. And I divide by the 4. And I get -3 is less than n. Now, I don't know about you guys, but variable on the right makes it harder for me to do interval notation. At least for me. So instead, I would rewrite that with the n on the left, the -3 on the right, and my vampire has got to be chasing the n. What is this in interval notation? I didn't ask you guys on the last one. Yeah. Good.
I don't know, I was thinking the original solution would be easier to put in the interval notation because the lowest number's already on the left.
For some people that is. That's why I said it out loud. Let me just write it. For me. Maybe you. Some people it's not. Some people like this seems much more intuitive. For me, I have in my head, like I see that arrowhead and the arrowhead doesn't work right when the letter's on the right. And so like the arrowhead, like if I treat this as an arrow, it's pointing to the left. And it's not supposed to point to the left. It should point to the right because it's graded. The very idea of saying -3 is less than n, like saying the letter last, like I have to really stop and translate what the hell that means. So if -3 is less than n, then n has to be bigger numbers.
Okay.
In my head.
Yeah.
He's like, shut up, I already got it. I know what you're saying. Shut the fuck up, Jones.
Yeah, I get you.
All right. Let's give you some more. Try that one for a little bit. Making sure you distribute first. You already done? Fucking go, Turbo.
Quick question though, multiplying a negative number, even in distribution on one side, that wouldn't change.
That doesn't trigger it. It's only when you're doing it to everything.
That's what I thought. Thank you.
You good, Jared? Oh, I didn't hit pause for that. Fuck it. Oh well, enjoy at home, viewers. You're 5 minutes sitting here watching me look on Telegram while everyone worked. Let's do this together. So if we distribute the -4, this becomes -4x minus 24. Then I still have my plus 18 greater than -2x plus 6. Maybe let's see if you guys got this. What answer you got first? What'd you guys get before I continue?
I got -6 is greater than or equal to x.
Okay. What'd you get, Jared?
You got X is, X is less than -6.
Okay, so you guys got the same answer, just on different sides. These are the same. So let's see if you guys are right. Hopefully. -4x doesn't do anything. I'm going to combine the -24 and the 18, make that -6. And then I will add 6 to both sides. It sounds like you went the other way and you moved the -4x to the right. So if you did it differently, you should still end up with the same values. Here we've got -4x is greater than or equal to -2x plus 12. Then I'd add the 2x to both sides. And I have 12 over here, this is -2x. And dividing by -2. The x is there, 12 divided by -2 is -6, and we flip the inequality. We're here with the old flipperoo. So yes, you guys both got the same answer. What's the interval notation on this one?
The -infinity, comma, -6 with the parentheses on the left and a bracket on the right.
That's correct. Good job. You guys want another? We're doing another. That was a nice try. I guess I phrased the question poorly. Oh, pause the video. Make them watch it again. So, I don't like fractions. You shouldn't like fractions either if you're human. I'm a mathematician, so don't tell me if you're a mathematician you should like fractions. It's not true. It makes numbers ugly. Fuck fractions. So we have a couple options with fuck fractions. The method I like is the LCD, but we will look at the decimal version in a second. The LCD here is pretty straightforward. We have a 3 and a 5, and so the LCD is 1 from each column. 3 times 5 is 15. So I am multiplying everything up here by 15. And that's the equivalent of the 3 times 5. So here, the 3's are going to cancel with the bottom, and we keep the 5 on top. Keep 5 on top multiplying. Over here, the 5's are going to cancel, and the 3's multiply top. So where that translates to the next line is I would have 5 times 4x, oops, write 4x when you say 4x, 5 times 4x minus 5 times 2 is less than or equal to 3 times 4x plus 3 times 3. I was about to say 5 times 4x again. I'm like, that doesn't sound right. You may have skipped that line if you did this and gone directly to this. And if we solve here, I'm expediting some actions here. you will get to the point where you have 8x is less than or equal to 19. Divide by 8. And we get x is less than or equal to 19 over 8, which is the same thing as 2.375. And the reason why I'm showing the decimal equivalent is because we're going to do this the other way with the decimals. The other way to say fuck fractions is to get rid of them by option B, convert to decimals. How far did you, what did you write, Jared? I'm kind of curious. How many decimal places did you write?
3 decimal places.
You went 3 decimal places? Okay, let's do that. So 4 over 3 is 1.333x, minus 2/3 is 0.667, is less than or equal to 4/5, which is 0.8 or 0.8x, plus 3/5 is 0.6. I'm gonna do that same process. I'm gonna move all my x's to the left. And I'm gonna add that number to the right. And I get 0.533x is less than or equal to 1.267. And so x is less than or equal to 1.267 over 0.533. And when we finish that out in a calculator, I'm getting x is less than or equal to 2.377. These are close, but not the same. This is off due to rounding. Which is fine. What I recommend you do is rather than just doing if you switch to decimals, let's do this on another page. If you switch to decimals, do a lot. I would go 1.333333x minus 0.666667 is less than or equal to 0.8x plus 0.6. And after subtracting 0.8x and adding 0.666667 to both sides, I have an equal sign in there. I'm just over here all over the fucking place. I'm gonna get 0.53333x is less than or equal to 1.6 or 1.2666667, 6 decimal places. I divide by that 0.533. Five threes, and I get I think I have numbers there. 2, 3, 4, 7 divided by 0.53333. I get x is less than or equal to 2.375002. It keeps going, 109. But now if you go like 6 decimal places, rarely will the homework ask you for more than 4. And by going to 6, you will likely be correct even to 4 decimal places. Notice if we round to 4 decimal places, we still have the 2.375 we had here. So the decimal route works, but I recommend writing a lot to keep the accurate number right. Because if you do it on the homework, it's gonna tell you you're wrong when you're off by that 0.002. Both methods work. I assume you didn't multiply by a bunch of numbers to get rid of the decimal. You just work with them as is. Okay. Both approaches work, but do several more decimal places than you think you're gonna need. Even though it has a little bit more here, it makes sure that your error or your answer is more accurate to more decimal places. Any questions? Well, let's let you go. This is enough for the day, right? Feel like you got a good math dose in today? You guys didn't take a break. Not really. Get the fuck out.